100. Lab number 24, we want to look at finding the zeros of a polynomial function. And what we want to do here is start off by listing all our possible rational zeros for this. And to do that, you want the factors of the constant on the end, factors of 6, over the factors of the leading coefficients. So the leading coefficient is 2. So the factors of 6 would be 1, 2, 3, and 6. Obviously, positive or negative on all of those. And then the factors of 2 would be 1 and 2, positive or negative on those. So our factors are going to be plus or minus, and I'm just going to list the numbers and realize that plus or minus is in front of each of them. If I divide 1, 2, 3, and 6 by 1, I get those numbers back. If I divide them by 2, I get 1/2. 2 divided by 2 is 1. I've already got that listed. 3 over 2. And then 6 divided by 2 would be 3. I've already got that listed. So those are my possible rational zeros. From there, I would take a look at the graph for this polynomial. So I'm going to graph it. And so calculator, y equals and 2x to the third minus 3x squared minus 5x plus 6. And then a graph. And this is what I'm looking for. I'm looking for where it's crossing the x-axis and what that could do for me to help me get the zeros for this polynomial. So grab that graph, bring it back to our notes. And we see in this graph that it's crossing the x-axis there. Looks like at positive 2, and that's positive 1. And there's somewhere between negative 1 and negative 2. And so what I want to use is one of those in a synthetic division situation to break the polynomial down. So I'm going to use the 1 in synthetic division because 1s are easy to work with. So then I would put the coefficients 2, negative 3, negative 5, 6, and then run the synthetic division with that. So that's 2, negative 1, and then we see that that is a 0. It's not a surprise because it did cross the x-axis at that point. So that tells us that that x minus 1 is a factor, or x equals 1 is a 0 of that. And that 2x squared minus 1x minus 6 is the polynomial that's left over. So we have x minus 1 here. That's the factored form of our polynomial we started with. And we can factor this a little further using the x method. So negative 12 add to be negative 1, be negative 4 and 3. It'd be 2x squared minus 4x plus 3x minus 6. And then group that. 2x, x minus 2, 3, x minus 2. And then that's 2x plus 3, x minus 2. And then we already had the x minus 1 factor. That allows us to then take those factors and get all my zeros. So I already know that x equals 1 is a 0. But if I take 2x plus 3 and set it equal to 0, and x minus 2 equal to 0, I get x is equal to negative 3 over 2. That's between negative 1 and negative 2, what we saw here on our graph, right there. And then this is x equals 2. So we get the zeros of x equals 1, x equals 2, x equals negative 3 over 2. The factored form is here. And these are our zeros of that polynomial. So no matter which of those values that I had picked to do my synthetic division with first, I will still have gotten the other two using factoring or quadratic formula, for example, to get those solutions.